We were just sort of winding down our discussion about templates, right? So I'll kind of pick up in that area and finish that out before we go to the next section. You ready? Okay, so what I want to do is I want to finish out our discussion about templates and STL, how to use STLs. So, I think let me make this a little bit fuller here. Okay, who knows what is a priority queue? Who knows what is a priority queue?
Priority queue.
Have you heard of it? So a priority queue is basically, let's think of a queue. A queue is a data structure that is first in, first out, right? So generally, and that's called a queue, but more specifically, it's probably better described as a FIFO queue, right? First in, first out, FIFO queue. So then we have another thing called a priority queue. Essentially, it's still a queue. So that the first elements in tend to be the first elements out, but there's also a priority involved. So for example, let's say you have a priority queue, and an element comes in, and then another element comes in. So maybe it goes second, but then a third element comes in, and it's more important than the other two. So we look at the priorities. So if you have a higher priority, you get promoted ahead of the lower priority elements. That's a priority queue. So for example, let's say priority is 1 is the highest, 5 is the lowest. So if we get a 5, and then we get a 4, the 4 goes ahead of the 5, because it's higher priority. And then if we, let's say we get another 5, that 5 goes in the back. Another 5 goes in the back. How about a 4? Skips all the 5s and goes next to the other 4. If we get a 1, it goes in front of everybody. So it's a priority queue. And priority queues are important because they handle first the highest, most important jobs. And typical data structure. So a couple of things are done here. So the first thing we do is we basically create a priority queue, STL, for strings. And then we have another queue here where we put in a STD greater string. Anybody know what that is? Anybody know what greater is? From our discussion last week. No? So, if you create a priority queue for type string, how do you think the priority is going to be done? Is it a priority queue at all? I mean, it's very simple. Priority queue string, priority queue int. Easy. How do you think priority is going to be made on a priority queue for strings if you don't tell it how to compare elements?
Based on the length size. Based on the length of the string.
Could be the length of the string, but more specifically, it's going to be based upon the alphabetic order or the alphanumeric sequence of the string. Okay, so strings that are earlier in the alphabet will tend to go ahead of the other ones. If you say, for example, if you add or push into the queue B, and then you push an A is going to go ahead of the B. Why? Natural order of strings. We have a natural way of comparing string elements. So that's how that's being done. But in the second case, what we have is we have a priority queue, also for strings, but the second thing we're doing is we're asking for the implementation, or specifically the adapter, okay? We're saying how to implement the container. We're saying implement this priority queue for strings, store it as a vector of strings, and for comparisons, use the greater functor. And that's what it is, parameterized for strings. So that's what we're doing. Now, so what we're supplying, in a sense, is the function, or in this case, the functor, the object that will do the comparison of two objects that are of type string. So you can specify anything you like in terms of like a function. You can specify a function to compare two strings. You could, for example, do what he suggested, and that is basically strings that are longer are more important. But then you need to specify a pointer to a function that takes two strings and then decides which one is going to be more important. So you can just do a function that says, okay, what's your length? What's your length? Okay, the bigger one goes first. And so once you supply that, the actual placement of the strings into the priority queue is handled by the STL implementation. Okay, so here, notice that we push Connecticut, New York, Maine, Utah, and Florida, and you can see CNMUF, and then we do another P2 is the other kind of priority queue, Connecticut, New York, Maine, Utah, and Florida. And so what we're going to see is that all we're trying to do, and now at this point, see how easy it is to program. You can say, while this priority queue PQ is not empty, see out PQ top. It's going to give me a top element, cast it as a string, and PQ pop. And that takes it off the top. And then in the second one, you do PQ2, empty, and I have the same exact code. Okay? One is a default, and one is the greater. And you can see the output is this the way I put them in? So why is Utah coming out first? What do you think?
Alphabetically, it's the last letter.
Are they? You can see that it's not by the lengths, because the lengths are not increasing, strictly increasing. But that's something I could ask you to do, right? So maybe for homework, what you guys can do is take this code and then write it so that the output is going to be in increasing length of strings. So if that's the case, then you're going to get Utah, Maine, New York, and Connecticut. Should look like this. So do that for homework assignments. Okay? Easy. This will take you, if you're struggling, it might take you a half hour. I don't think it'll take you too long. Yeah?
Why do you use STD for the in program?
I'm sorry?
In program, why do you use STD for the greater initialization of greater?
Oh, maybe somebody can answer that question.
Yeah,
Why here, right?
Yeah.
So, what's your name?
Aditya.
Aditya?
Yeah.
Aditya, okay. Aditya wants to know, why do we use string here?
No, STD daughter. Why?
Standard.
Because we decided if we are using namespace STD.
Oh, I don't have to do it. I don't know why. It won't hurt it, but it's not necessary. Okay, yeah, so we don't need the STD here because it's already using that namespace. Okay, so clearly Notice that it's U, N, M, F, so this is going in alphabetical order. So it looks like the default is going to be what? Highest priority is the highest alphabetical. Who made this decision? Whoever implemented the template. Okay? In the second case, what's going on here?
Natural.
It's an alphabetical order.
Well, they're both in alphabetical order, but this is forward order and this is reverse order. Okay? But what I want you to do is I want you to make one small change. See if you can provide a functor or a function pointer, either one, so that when you run this code, and the code is right there in the notes, so it's easy to do. When you run this code, you're going to get from short, and you can add some more to it too. Okay? That's a fun assignment. It's not overwhelming. You don't need, 35 pages of documentation.
Wednesday.
Huh?
Do you want to Wednesday?
Yeah, should be due on Wednesday.
Yeah.
I think so, yeah. If you have any questions, talk to this guy. All right. So here is now this will give you some idea of how you can do this. So what I'm going to do is I'm going to create a class. This class is going to be called My Comparison. And notice that I'm including the Q. My comparison has a, is this private or public, the bool? Private. Why? Default for classes. If this, what would make it public? What do I have to change here?
Public class?
Change class to struct, and then everything is the same, except that this goes public and this is public. Everything's public. It's just testing if you remember. Okay. All right. So now the reverse is just a private property. My comparison constructor takes a const bool reference and then reverse parameter equals false. What's that? Equals false. Do you know what that is? What does it mean equals false? Do you remember what happens we're in the class declaration here, but we are doing everything in line actually. What does it mean if you have a parameter equal to false? By the way, I'm missing a comma here. I don't know why. Constant bool reference. Okay, so what is this over here?
You're assigning it to false?
So it's what kind of parameter? Default, right? Default parameter. Okay. So basically, that means I can call this thing with how many parameters? One or none. So it's a const bool reference reverse parameter equal to false. That means if you don't provide it, I can call this thing without any parentheses, which means it's going to default to false. But if you call it with true, it's going to go to true. Okay? Everybody understand that? Good. Okay, good. Well, you said something. Okay, so basically, this is the constructor, right? Constructor. Okay. The parameter is a bool. Constant reference Boolean. It's called rev param. Equal to false means it's the default value. So that means if the value is not provided at all, it's going to go to false. Okay? That parameter is going to go to false. But if you provide a value, false or true, it's going to say whatever value you put in here, and that's going to assign it into reverse. So reverse will be assigned false if nothing is given, or whatever is given will be assigned into reverse by default. Okay, and you'll see how we're going to use it. Now, tell me what the heck this is right here. Bool operator. Parentheses, const int reference LHS const int ampersand RHS. Anybody can tell me what is this thing?
It's an overload? Operator overload?
Yes, it's an operator overload, but be more specific. What's the return type? That's a type. So what kind of overload is this? Doesn't look familiar? Well, we're overloading the parentheses operator. So what are we doing? We're creating a functor. Yes! We're having some fun with a functor. Okay, so we're creating a functor. So basically, it's the parentheses operator which is taking parameters here. Const, int, ampersand, LHS. Think of that as left. And const int reference RHS, which is going to be right. So, so once we create an object of my comparison, you can pass it two values. All right, so it's going to be an operator. Now it says if reverse. If reverse. That means if reverse, if my parameter reverse is true, return LHS greater than RHS, else return LHS less than RHS. Okay? Does that make sense? You have any idea where I'm going with this? Anybody have any I know you do. I know you're suspecting what I'm doing. Anybody have any idea what I'm doing with this, James? This is your homework. This is basically what you're going to be doing. Okay, so you're going to create a class like this. You're going to create a functor. So the functor called so basically the functor is the object my comparison. And when you say dot, when you say parentheses rather, is going to invoke my comparison as a function, passing in two parameters. Okay, so the parameters are going to be the left-hand side and the right-hand side. If reverse is true, then we'll return the condition that LHS is greater than RHS, else we'll return a condition LHS is less than RHS. So it's the opposite, right? They're going to give me opposite results, pretty much, right? Okay. So okay, let's see how it's being used. So I'm going to create an array myInts, which I initialize to a few values. And then I'm going to create a priority queue for int. Priority queue for int first. So that means this is my first priority queue. Now, how do you think the default implementation of the template will order my ints as a priority? Take a lesson from the strings. What do you think is going to happen?
Largest first. Largest first.
Yeah, biggest values first, because that's what it did for strings. And actually, it's the same code. It's the same code. This is priority queue int, the other one's priority queue string. So you know that the code is written, template class T, and T is now an int, and before it was a string, but the code is the same. So we expect the logic to be the same. It makes sense. It's the same darn template being generated for a different type. Okay, so now priority, so this is first. Priority queue in second, what I'm going to do is I'm creating this priority queue and I'm putting into the constructor my ints. What's that? That's my array. So I'm putting a pointer to my container and then my ints plus 4. Do you see what I'm doing here? So I'm putting in, so what's this over here? It's the pointer to the 10. What's my ints plus 4? No, it's a pointer after the 20, right at the end of 20. So it's the pointer at the two outside edges of the container. Okay, now I'm going to create a third priority queue. Priority queue. What type? Int. So it's going to be, those are going to be, the parameters are going to be int. What's this? Vector int. I'm telling it to store my priority queue as an array using a vector of int. And finally, I'm going to use greater int. You know what that's going to do, right? That's a functor, right? And that's called third. And I'm also saying it my ints and my ints plus 4, same thing as before. And now I'm going to use my comparison. Because my comparison is the custom functor, if you will. So priority queue, int. Again, our elements are always going to be int just because we're messing around with this int array. Vector int is going to be my storage mechanism. And then my comparison. So my comparison, what am I doing? What is my comparison? What is this? What, describe in one word what this is. It's a what? It's a what? Okay. So it's a class name, so we're basically constructing a default object, right? So that's what we have. So my comparison is a class. Really should be uppercase M. Right? So I'm constructing a default functor. Okay? Now, next line. Type def, priority queue, int vector, int my comparison. My PQ type. What am I doing here?
Macro?
Not a macro. I'm creating a type. So what's the name of the type? The type is called my PQ type. And what is it? It's type equivalent to fourth. Fourth is a priority queue of ints with a vector int and a my comparison functor. My PQ type is a type of priority queues for ints, vector int storage, and a my comparison functor. So I basically made a type of the same thing as fourth is. So now I can say my PQ type fifth, my comparison. So my fifth is immediately exactly the same type as the fourth, and I'm putting in my comparison into the constructor. And lastly, I'm saying my PQ type 6, my comparison, true. Because when I have a my comparison constructor, what's the default? False. So this is going to put the functor object into the constructor here as a false, but this one, because I'm providing a true, it overrides this, and therefore reverse parameter, true, is assigned into the reverse property. Okay, so what's going to happen with this? I didn't really do anything. Now, if you want to find out what this code is going to do, you need to finish this code with something like this to find out. That's what I want you to do. Because it's a priority queue. So you're going to find out, so you're going to have to put some stuff. You can create more arrays. So take this code. If you want to find out how this functor is working, run this code. But do some outputting, because I don't have any output here. Okay. So we have containers, we have adapters, we have algorithms. There's an algorithm called find. So let's see how that's going to work. So I'm going to use a set, so I'm including the set STL. I'm going to use an algorithm on the set, so I'm going to include algorithm. Okay, so the first thing I do is I create my set object, which is a set of int values. Once I have it, I can use any of the available operations. I can basically insert a bunch of values. 1, 5, 3, 11. Then I'm going to try to find 3 in the container. So I'm going to create set int iterator, my iterator. So what's my iterator? What type is it? What type is my iterator? I'll give you a hint. It ends with pointer. What type is it? Okay, if I wanted to assign the first element of the set into my iterator, how would I do it? My set dot my set dot what? Starts with a B. Begin. So that tells us that my iterator is what type? It's an int pointer. That's right. It's an int pointer. Okay. So therefore, so this is an int pointer. So now we understand that this is an int pointer, and it points to what? It points to ints. Why? Because this is a set of ints. So I want to have my iterator take the reference of an element that I'm searching for. So I'm now going to use the algorithm find my set begin. You know what that does? starting address of the set, myset.end, and 3. So I'm looking in this range of int values for the occurrence of this value of 3. So I'm checking if my iterator is not equal to myset.end. What do you think that means? What do you think it would mean if my iterator was equal to myset.end?
Is it set the
There's some value.
It didn't find it. That's why the pointer pointed to the end of the container. So if it's not equal to the end, then see out star my iterator. And you can see that my iterator basically is an int pointer, just dereferencing the pointer of the element. You can see how cool it is and also how dangerous it is. Because really, if you have this container, giving a pointer to it is really kind of dangerous. Because now you can change the values in the container. So it's a little bit, it's a little bit crazy. But C++ is like that. Okay, and then else means that it's equal to my set.end. Therefore, I'm going to say error 3 is not in the container. So I can determine that. Another cool algorithm is the for each algorithm. So for each allows us to do something with each element of a container. So let's say I want to add a value to a container. So what am I going to do? I am going to, can you tell me what I'm doing here? Functor. Okay, now you guys are catching on. Okay, so you can see a class. I'm creating a class called addValue. I have an operator, which is a parenthesis operator. It's taking a parameter. So that is creating a functor. So creating a functor that takes a reference to some type t. Not only is it a functor, it is a templated functor. So it's a generic functor, where the value of the addValue is generic. It's just type t. So the constructor takes some initial value of type t by reference and sets the value equal to that v using the member initializer. And then we have this overloaded operator, which makes it a functor. And so notice that the operator overload here is taking the element by reference, which means I'm able to change the element because it's coming in by reference. So the first thing I do is I say vector int v. So I'm going to create a vector of ints, and I'm going to insert some int values into the vector. I'm not showing that. And then what I'm going to do is I'm going to say for each. So this is the algorithm coming from, I don't have it here, but from algorithm, pound include, for each. So here, okay, you see what it says over here? Ignore that. That should be v begin. There's some crazy stuff going on here. V begin, comma, v dot end. And then I had add value int 10. You see how that, so what is add value? That is a constructor of a templated functor making it an int with 10. So what happens is this constructs the functor 10. Okay, there's a problem with this code. What's the problem? Who can see it? No, I mean, this part is not the problem. The problem is here. I can't take the 10 by reference. That's not going to be good. I can't take the 10 by reference. But, so what I need to do is I need to remove the ampersand, because 10 doesn't have a reference. It's a constant. Okay, so 10 comes in, and then the value gets the value of, in this case, 10. And so for each, what's for each going to do is for each is going to go through the entire container, and it's going to send each element of this container v, this should be v and v, into the parameter of, it's going to say, so basically this is it's going to create an object of some type. Remember, this is just an object of some type. It's going to call this object as a function, which means it's going to invoke the functor, sending in each element of the container by reference. And then the element by reference plus equals the value. So it's going to increase each element in the vector by 10 using a functor. That's what you guys are going to do. You guys are going to create a functor that's going to do the comparison for a length of the string, where you can just compare the length of the string. All right, I think that's probably good right there. Okay, so this is the last slide of this one. So basically, STL, we did the for each addition right here. Additional algorithms that are available in STL are copy, swap, transform, random shuffle, which is very useful for randomizing stuff. Sort, you don't like sorting? Just say sort. And you can say sort from begin of the container, end of the container. Okay? And then you can provide, if you want to, you can provide a functor to do the comparison, similar to what we did here. Binary search, very nice. You'll do a binary search of the container. For each, you've already seen. Min element and max element will quickly find the minimum and the maximum elements of containers. Okay, so that's good. All right, so now let's go to kind of a cool, slightly esoteric part of C++, which I call special pointers. And we're going to be talking specifically about three types of pointers. One type of pointer is going to be called a smart pointer. So we like smart pointers because they're smart. So right away, we all want to be smart, so we want to be like a pointer. We want to be smart. So we're going to do that. Let me just try to get this thing up again, sorry. And the other, so a smart pointer is essentially, well, you'll see what it is. And this is going to sort of roll us into design patterns at the same time, because this is related to design patterns. It's a kind of a design pattern without formally going into it, and you'll see how it works. So a special pointer. So the first one is going to be called a smart pointer, and then we have something called OPMs. OPMs are offset pointers to members. Offset pointer to members. That means we have pointers to properties within objects. So they're pointers. So for example, if a class like rational has two int parameters, I could ask for an offset pointer to the bottom property or the top property. So it will be an int pointer, but its type will be a rational member int pointer. It's a different type than an int pointer. Okay, so those are called offset pointers. Okay, so, well, there are two of them, two OPMs.
Okay.
Yeah, there's offset pointer to member and offset pointer to member function. So one is a functional pointer to a method, and one is a property pointer. So that's three. And the first one was the smart pointer.
Okay.
All right. So we're going to add a couple of things here. So smart pointers and offset pointers to members. Let's add a new element, some new elements to the rational class. So here's what we're going to add. We're going to add a type def right inside the class in the header file. So we're going to type def double rational : star RFP parentheses. Okay, what the heck is that? Well, first of all, it doesn't look too bad at all. If you get rid of the rational and then the double colon, it just looks like a pointer to a function that takes no parameters, returns a double. Right? That's all it is. We are like totally savvy with that. We get it. So RFP looks like a pointer to a function that takes no parameters, returns a double. But now let's add in all this garbage here, and what it means is RFP is a pointer to a function in the rational class which takes no parameters and returns a double. So we're saying not only is this a functional pointer to this type of function, but it's a rational pointer to this type of function for this class specifically. So that gives it a type that's very, very, very specific. It's not just pointing to any old functions, it's pointing to methods of this class that have this property behavior. And if you look very carefully down here, I've added two very sneaky methods. So double square root and double square are two different methods, but they are both members of rational. Therefore, they both have no parameters coming in, and they both have a double going out, so they look like a perfect type match for RFP. Is RFP a pointer to a function? Is RFP really a pointer to a function? Go ahead.
The void pointer.
No, it's not a void pointer. Is RFP really a pointer to a function? And the answer is no, because the additional type def. So basically, it's not even a pointer to a function. It is a type which allows pointers to functions from this class that have this profile. Does that make sense? It's a lot. The type def is the killer, right? But save it for last. Okay? So RFP is a type. It can't point to anything at all. It's a type of thing. So RFP is a type of functions that are members of this. That means methods that take no parameters, return a double. Now, notice that this type def is in which part of the declaration? Public or private? Public. Which means that other clients and subclasses can see the identifier RFP. Okay, so finish this short question. RFP is give me a 4-letter single word. Say it. Type. That's all I want. Now, you might say, well, how do you know that? Well, he's super smart. He's paying attention. But when I give you a final exam, I will give you a final exam that will have a challenging part, which will be a matching part. So you'll have one set of stuff on the left-hand side, one set of stuff on the right-hand side. And I'm going to try to make sure that there's exactly one match that's going to be a perfect match. And it's not going to be totally obvious. But you'll do the easy ones, you'll have the harder ones, and then you'll basically say, well, it is that. It's the only one, the other ones aren't. So I'm going to have you focus in on things. I'm going to ask you questions like that. So as we proceed, I'll give you more questions that are going to be like very focused, very single-minded questions. Okay. So other than that, everything else is pretty much the same. We add these two methods with the same signatures as this type of pointer. Okay? And so now we're going to write here. So this is still the same thing here. So so it displays the method. Fwrite, we've seen that before. This is our binary write. Fread is our binary read. And then we're going to have static int rational : start get prop offset char star field name. It's really getting interesting. And then we're going to have static RFP get method offset. So this is a function. This is a method, right? This method returns an RFP type. What's an RFP type? It returns pointers to functions that fit that profile that we saw before. And it will take as a parameter a C-string method name. So if somebody's looking for a method name that's called square or square root, I might be able to give them an RFP for that. So what's RFP stand for, you think? I know you know FP.
Rational function. Rational function.
Yes. Okay. So see. So RFP is basically, FP is a functional pointer, and RFP is specifically it's catered for rational, so it's a rational function pointer. So if you give me a string, and if the string compare of your C string and square is equal 0, that means they're the same character for character. That means you want an RFP to the function square, so I will return to you rational : square. What's square? Square is this function down here. That's the header. So if it matches square, I will return to you the address of rational colon square. By the way, if you forgot the ampersand, it's okay, because we don't need the ampersand. C++ will allow it to go with or without the ampersand. Functional pointers are like that. If the string compare method name and square root, if that string compare method returns 0, that means all the characters are the same, then we will return the address of square root, which is a method. Okay? Now, if we return something, that means we succeeded to return something. Otherwise, we'll return null. Returning null will happen only if I don't return here or don't return here. That means you're asking me for a method I don't have. And then we finish off with the private data. And of course, what are the properties that we have? They're called top and bottom, right? Top and bottom. So that's what this getProp offset returns. GetProp offset, rather than give me the name of the method, I'm going to send it the name of the property, which sometimes is referred to as a field. So if I send you a field, I'm going to do the same thing. If the string comparison of the field name you sent and top, if the string compare of that returns 0, they are the same. So I will return to you rational colon top, its address. I will return to you the address. And the type of the address is a rational top pointer. Rational pointer. Okay? Yeah.
Why would you ever want to do that like that?
Well, it's for advanced programming, and it's when you need to get into stuff and really kind of, you typically would not want to do this normally. That's a good question, but this is how you would do it if you wanted to do it. Notice that, what type am I returning? I'm returning a rational class pointer to int. A rational class pointer to int. If you get rid of the rational stuff, you're just returning an int pointer. You are returning an int pointer. Top and bottom are ints. But specifically, they're not just plain old int pointers. They are property int pointers from the rational class. So they're rational int pointers. And that means they are rational property int pointers. Okay. So here is the method square root. Very simple. No parameters, return. Now sqrt is the math library function. So take the square root of double cast of top over bottom. So that's it. So I'm basically casting the two integers as doubles and returning the sqrt as a double. That's it. Very simple. To square, I do the same thing, kind of thing. I use the math function pow. So power. What is star this? What am I doing? Anybody know?
Top by bottom value.
Say what?
Value of top upon bottom.
How is this powering this thing? What's this?
Rational object?
This is a rational pointer, right?
Yeah.
What's star this?
The actual rational?
The rational object. What's double?
Yeah.
Casting it to a double.
Say again.
Casting it to a double?
Yes. How can I do that?
No, the
You're right. I mean, I am. But how am I able to do that?
because you made the function root?
No.
Oh.
Because I created a casting operator. So, and I don't know if it's showing here or not. Yes. See it right there?
Yeah.
Operator double. It's a casting operator. What's the difference between a casting operator and a functor?
That's specifically for casting.
It's very subtle. I'll show you.
The type.
If you wanted to, you understand, you could basically make this a functor if you wanted to, right? But if you wanted to make it a functor, you would say operator, this is the return type. This is going to overload the parentheses operator. Then you need another set of parentheses, the parameters. That's a functor. If you simply say operator, double, close parentheses, semicolon or code, that's a casting operator. That's the difference. So notice what we have here. Operator, type, parentheses, code. Operator, type, parentheses, code. But in a functor, which I don't have any more on these slides, you would have operator, type, parentheses, next set of parentheses with the parameters, code. It's a subtle difference. But that's how you can tell. Do you want me to show you on the old slides?
Isn't it just reverse? Type, operator, type, and then the overload? That's how it was for the Boolean functor.
I think you're going to have two sets of parentheses though. Because you're overloading the operator. So for example, if you're overloading the plus operator, you're going to say operator plus, right? And then you're going to have what?
Yeah, the thing that you're...
Parameters.
Yeah.
But with a functor, you're going to have operator parentheses, and then you're going to have the parameters. So you'll have the operator always empty because that's the operator. Operator parentheses, and then parentheses for the parameters of the functor. But if you have a casting operator, you will not have those second parentheses, and the first parentheses are always nothing in them. Always. Do you want me?
No, I got it.
You understand? Everybody understand? You want me to show you the other way? Let me show you real quick, and I'll come back to this. We don't have that much to do today. We're almost done anyway, so because I'm going to keep it short today. But let's see. So if I go back to so the previous nodes. Okay. I think we can look it over here. So where's the functor? Functor's right here, right? So notice what we have, bool, operator. We're overloading the parenthesis operator, and here are the parameters for the parenthesis operator. That's a functor. If I said bool, operator, parenthesis, and then I had code, that's a casting operator. Because a casting operator, you cannot have any parameters.
Yeah, I can't...
But a
see it.
functor, you could. So let's say you didn't want any parentheses, any parameters to the functor, then you'd have to say bool, operator, parentheses, second parentheses, code. That would be a functor with no parameters.
Yeah, right now the brackets and parentheses look the same to me. So
Why?
That's why I just can't see the difference right now. It's too
Hold on a second, too small? Okay, so these are brackets, right?
Yeah.
These are parentheses.
Yeah,
So basically we're saying Boolean operator. So at this point, we don't know if it's a casting operator or a functor. But once we hit an open parenthesis, we know it's a functor. Because a casting operator cannot take parameters. So we do not allow any parentheses follow the parentheses specification. So when we have the rational double casting operator, it just says double operator parenthesis code, and it will return whatever you say the code does. Big because it was a little small. Okay, so these two methods are part of the rational class. One is returning an RFP, which is that type def that we have. And the other one is returning the address of one of the properties of this class. So this is, so I'm going to go back there. So this clearly, you can see, is this a functor or a casting? You can see why, right? We have operator, return type, parentheses, code. Operator, type, parentheses, code. They're both casting operators. Okay. All right. So the last thing we're going to look at is we're going to look at something called a smart pointer. The smart pointer, I will just say one thing, is basically it is a type of a design pattern which is referred to as a proxy pattern. You guys have heard of proxies, right? Server proxy, this kind of proxy. There are a number of different proxy patterns. This is one of them. The way this proxy pattern works is that you have an object. You do not give the object reference for use. What you do is you wrap the object in another object and you give the access to the outer object. And when somebody invokes an operation on outer objects, it triggers the behavior on the inner objects under controlled circumstances according to the way you want that access to go. For example, let's say you wanted to allow somebody to access an object 10 times. But after the 10th time, no more access. So what you could do is you could create a proxy. That proxy essentially would be counting the number of accesses that you've had in this object. Once you went to 10, instead of giving you access indirectly to the object that's hidden, it would just basically give you a null pointer or give you an exception or whatever the case may be. Okay? So a proxy basically allows you control over to some resource that you don't want to be arbitrarily accessed however somebody wants it. Okay, so let's take a look over here. So we're going to create a class called smart pointer, and the smart pointer constructor basically takes a top and a bottom in parameters, and then it creates an R pointer that's a property, so we'll have to see what exactly that is, and you can see an R pointer is just a rational pointer. So it initializes the R pointer by constructing a new rational with a top and bottom parentheses. And then secondarily, it initializes the access property, which is an int, to 0. So the smart pointer basically is the outer object, and on the inside we have a pointer to the rational. The rational is the resource. That's the one we are trying to protect and control access to. So the rational is on the inside. So notice the smart pointer has a pointer to our rational object. Okay. Now, so let's see what else we have over here. So some interesting things going on here. So we have rational, that's a type, star, operator, pointer, parentheses. What the heck is going on here? So this is the get method for a rational pointer. So what does it return? What's the return type? The return type is rational star. What is the method? The method is operator pointer. So we are overloading the pointer operator. And we are returning from the pointer operator a pointer, which is very nice of us. Quite frankly, because if we wanted to return something that's not a pointer, we could really mess around with somebody. I'm using a pointer, I'm expecting it, and it's not a pointer, we're just not returning a pointer. So the pointer operator is returning a rational pointer. What does this imply? Why do we need this? Because an overloaded operator is a function, is a method. So therefore, all we're saying is that there are going to be no what?
No parameters.
No parameters? Okay. So now we're going to say access plus plus, access plus plus. What's access? That's our private counter. And return our pointer. So we'll bump the access and we'll return our pointer. Which is, return type is matching. Now, the client will have access to which object? The client will have access to which object? The smart pointer. And how will the client get access to this rational pointer? How does it have to access this, the code we just looked at? It's going to use the pointer operator. So it's very strange. The client will have access to a smart pointer object, which by the way is not a pointer, it's just an object, right? So the client will have access to a smart pointer object, but they will call on this object the pointer operator, even though it's not a pointer. This operator will in turn bump some local counter and then return an R pointer to the client. It's very strange. Very strange. Okay. And now, let's take a look what we have here. We have rational operator, parentheses, parentheses, access plus plus, return star R pointer. So here, we have rational is the return type. What are we doing? Overloading the parenthesis operator with no parameters coming in. This is not a parameter list. This is the name of the operator. This is the parameter list. This is not the parameter list. Of course it's not. It's the operator. So this is signifying which operator you're overloading. This is signifying which operator you're overloading. This is signifying if any parameters are coming in, and you have to leave it empty if they're not coming in. So what I'm going to do is, if somebody uses this particular functor and they say parenthesis, now how are they going to invoke it? They're going to invoke the smart pointer object with parentheses, which will call the functor. It will call this operator, which will bump the access of the object, and then it will return the dereference R pointer, giving the impression that the client has received directly a rational object. Okay, so let's see how that's going to look. So here we just have two headings. So I'm going to kind of combine everything here in a big crescendo of stuff going on. So count occurrence. So what I'm going to have is I'm going to have int rational colon pointer. What is that? That's a pointer to ints from the rational class. So that matches kind of like top and bottom. And then I have rational bracket. That's an array of rational. And then I have int, and then I have an int. And then I have some occurrence, which is going to be, again, the same type of pointer, array of rationals, and int. Then I'm going to have another method called execute method, which is going to take an array of rational, and then it will take what? What the heck is this? Okay, let's take a look what's going to happen here. So the first thing we're going to do is we're going to create smart pointers. That's the easiest part of the code. So basically, smart pointer R1, 2, 3, R2, 3, 4. So now, if I didn't call it smart pointer, I could call it my rational. And somebody says, oh, I have a my rational object. And I'm going to construct it of a 2 and a 3, and it's one of a 3 and a 4. I'm calling it smart pointer because I want you to understand what we're doing. So basically, the person thinks they're constructing a rational object. Because they're giving it this kind of stuff. Of course, what does the smart pointer turn around and do? The smart pointer basically creates a new rational object and stores a pointer to it in its own property. So that's what's going on here. So R1 and R2 both have rational pointers as properties, and they're pointing at a rational object. So is this one. Now I'm going to say R1 pointer display, parenthesis. So what's going on here? So what does R1 pointer do?
Returns the reference for R1. Or returns the pointer for R1.
It returns a pointer to the inside rational object, which then invokes the display method. So you're displaying the method. So R1 pointer, so you're displaying the R1 value, you're displaying the R2 value. This is very simple. So what are we doing here? Thank you. Okay, so look at this rational operator again. So we have rational operator, parenthesis, parenthesis, and then look at this code over here. So what is this doing? What type is R2 parentheses? It's actually a functor. What is it returning? What is it returning?
Point,
Mm-hmm.
or the reference inside the R pointer.
It's returning the dereference inside rational. So it's returning a rational object. So what happens here is that this is R1. This is just this is the easy code. R1 is just so this is R1 is the smart pointer. Pointer dereferences the inside object, invokes the plus operator on the value of the dereference hidden object inside of R2. And then I have what is show access. So show access, will we look at that one? So get access, return access. What's access going to be doing?
Counting the number.
It's just going to be counting every time you access that object. It's going to be counting. And again, it can say if the count is too high, you're done. So at this point, it says R1 access, R1 show access. Do I have show access or just
You have
get access? I think it's probably it should say get access. I don't know why it says. Probably changed it at some point in time. And R1 show access or get access value equals R2 get access value equals R2 dot display. So every time you access that inner rational, it's going to get counted. And you can say here the same kind of stuff is going on, very similar code. All right. Let's stop here. I think I've give you guys enough stuff to, we're almost done. So I'm going to give you, rather than getting into this hot and heavy with the OPMs and OPMFs, these are OPMs, are offset pointer members and offset pointer members functions. We already saw them. We're gonna basically look at the application of how they're used. OPFs, offset pointer to member functions, and OPM, offset pointer to members. Okay, so we'll pick it up on Wednesday. So for Wednesday, you guys are gonna do a little functor thing, and you're gonna be able to demonstrate that to our great GA. So when is it? Just and if you want to, you can do it as a group of two. Just to get it done. Have some fun with it. Have some functor with it.